High above the tropical forests of eastern Indonesia, on the island of Java, there is a volcanic crater called Kawah Ijen, a place that doesn't behave like the environments most people associate with Earth. Instead of flowing lava or explosive eruptions, this landscape leaks chemistry. Inside the crater sits a vast milky blue lake saturated with sulfuric acid, while beneath it, heat from deep within the planet forces toxic gases upward through cracks in the rock, releasing them into the open air where they transform, react, and sometimes ignite into electric blue flames. It is remote, difficult to access, and continuously active, not in dramatic bursts, but in a constant, controlled release of heat and gas that reshapes the environment in real time, creating one of the most chemically aggressive and visually surreal places on the planet. A place where the boundary between solid ground, liquid water, and breathable air begins to break down, where the atmosphere itself participates in the transformation of matter, where invisible gases rise from beneath the surface and reorganize into something far more dangerous the moment they meet the conditions above. The ground ahead is no longer uniform. It fractures, opens, releases faint wisps that dissipate and then reappear, not continuously, but rhythmically. Deep below the surface, heat is doing something relentless and precise. It is breaking apart minerals, stripping atoms from stable compounds, forcing elements into new configurations that cannot exist under normal surface conditions. Sulfur, locked within rock for thousands or millions of years, is being freed, transformed into gas, driven upward through fractures that act like microscopic highways connecting the interior of the planet to the thin boundary where rock meets air. That gas is primarily sulfur dioxide, an invisible compound that carries energy, instability, and potential. On its own, it is already dangerous, already capable of overwhelming the human respiratory system, but here it does not remain alone for long. The atmosphere above this landscape is saturated with moisture, not in the form of visible clouds or humidity you can feel on your skin, but as microscopic particles suspended in the air, waiting, available. When sulfur dioxide rises and meets this moisture, a transformation begins. It is not dramatic, it is chemical. Molecules collide, rearrange, stabilize into new forms. Sulfur dioxide reacts with water to form sulfurous acid, and under the right conditions, with enough oxygen present, that compound continues to evolve, oxidizing further into sulfuric acid, one of the most aggressive acids found in natural environments. This reaction does not happen in a lab. It happens here, continuously, in the air you are breathing. The atmosphere becomes a medium of transformation, a space where invisible gases are constantly converting into microscopic droplets of acid, suspended just long enough to be carried by wind, by thermal currents, by the subtle movements of pressure that define this landscape. You don't see the reaction happen, but you feel its result. Your throat tightens slightly. Your eyes begin to water, not dramatically, but enough to signal that something is interacting with the most sensitive surfaces of your body. The lining of your respiratory system is not designed for this. It is built for oxygen, nitrogen, trace gases in stable ratios, not for reactive compounds that begin interacting the moment they make contact. The air here is not neutral, it is active, and everything exposed to it begins to change. Metal surfaces dull faster than expected. Fabrics lose their integrity over time. As you move deeper, the ground begins to reveal something else, something that doesn't resemble typical water. Pools appear, scattered across the terrain. Their surfaces are naturally still, reflecting light in a way that feels almost synthetic. The color is wrong. It is too vivid, too saturated, a milky blue that shifts depending on the angle of light, as if the liquid itself is interacting with photons differently than normal water would. These pools are not water in the way you understand it. They are the result of groundwater being pulled into the same system of heat and chemical transformation happening below, rising back to the surface, carrying dissolved minerals, acids, and compounds that give it properties far removed from anything safe or stable. The temperature varies, sometimes warm, sometimes near boiling, but the danger is not just thermal, it is chemical. The pH of these pools can drop to levels that approach the lower limits of what liquid water can sustain, meaning that they are capable of breaking down organic material, reacting with skin, altering surfaces in ways that are immediate and irreversible. The color comes from suspended particles, dissolved sulfur compounds, and the interaction of light with a medium that is no longer pure. Standing near one, you begin to understand that this environment is not hostile in a single dimension. It is hostile in layers. The air reacts, the ground releases, the liquid transforms, and all of it is connected through a system driven by heat, pressure, and chemical instability. The pulses beneath your feet continue. They are subtle, but once noticed, impossible to ignore. There is a combined with the visual cues, the rising mist, the shifting air, the subtle distortion of heat. It becomes clear that this environment is in constant motion, even when it appears still. And yet, despite all of this, life is not entirely absent. It is reduced, minimized, pushed to the edges of what is possible, but it exists in forms that do not resemble the life you are used to noticing. Within the soil, within the thin films of liquid that coat certain surfaces, within the boundaries where acid meets mineral, there are microorganisms that have adapted to conditions that would destroy most known life forms. These are extremophiles. They do not avoid the chemical environment, they use it. Sulfur compounds become energy sources. Acidity becomes a stable condition rather than a threat, and metabolic processes evolve to function in environments where conventional biology would fail immediately. These organisms are not visible in the way plants or animals are, but their presence is measurable, detectable through the chemical changes they induce, through the byproducts of their metabolism, through the subtle ways they influence the environment around them. They are not surviving despite the conditions, they are surviving because of them, and this changes the way this place is understood. It is not simply a dead zone, it is a different kind of ecosystem, one defined not by abundance, but by specialization, by the ability to operate at the edge of chemical possibility. This has implications beyond this location, because environments like this are not unique to Earth. Moons like Enceladus, orbiting Saturn, show evidence of subsurface oceans interacting with geothermal heat, releasing plumes of material into space that contain water, salts, and organic compounds. Data from missions like Cassini-Huygens suggest that chemical energy sources exist in those environments, potentially supporting life forms that operate under conditions very different from those on the surface of Earth. When you observe extremophiles here, functioning in acid, in heat, in chemically aggressive environments, you are not just looking at isolated anomalies, you are looking at proof of concept. Life does not require comfort, it requires energy, stability within its own system, and the ability to adapt to the conditions available. And here, those conditions are extreme. This place does not need to be witnessed to exist. It does not need to be understood to function. It is simply one expression of what this planet is capable of when the conditions align in a way that favors transformation over stability, reaction over equilibrium, and motion over stillness. I post videos that break down how reality actually works from your brain to your body to the world around you, so if that sounds interesting, subscribe and I'll see you in the next one.